90 degrees. All right, the next thing I want to talk about is the impact bloodstain spatter patterns. So, what is impact spatter? It's the pattern produced when an object makes forceful contact with a source of blood. Projecting drops outward from the source. And we have two kinds. We got two kinds here. We have forward spatter. What is forward spatter? Well, it's spatter that keeps going in the same direction that caused the impact, as the force that caused the impact spatter. So, if a baseball bat, say, hits you from the right-hand side, blood that goes out the left side is considered forward spatter. Back spatter is blood that's directed back towards the source of the force. So we did a little drawing here. We got a little dude here. Let's do a gun. Let's put a little gun, bullet. Okay. So the direction is going towards the left now. We see towards the left of our paper. Okay. Source of blood. Well, forward spatter would continue going in the same direction. So these 3 blood drops would be forward spatter. Back spatter would go back towards the direction from which the impact came from. So that would be on the right side there. Forward spatter, back spatter. We also have classifications based on the velocity of blood droplets. A note that I want to, a phenomenon here is, as the force of impact on the source of blood increases, the velocity of blood droplets leaving the source of blood also increases. So as the force increases, the velocity leaving also goes up. The speed also goes up. That kind of makes sense. However, as the force and velocity of the impact increase, actually the diameter of the blood drops actually decreases. The blood droplets get smaller and smaller and smaller as the hit becomes faster and faster and faster. Think a baseball bat versus a gunshot bullet. Okay. So we got low velocity spatter. We have medium velocity spatter, and we have high velocity spatter. Well, what would cause low velocity? What do we consider low velocity? Well, gravity. Gravity we would just call low velocity. Let's put that here. Okay, medium. Say baseball bat or a knife, a samurai sword. Medium velocity. High velocity we would consider like a gunshot bullet. Okay, well, how fast are these things actually going? How fast? These don't have to be, you don't have to memorize these numbers. Just in general, we're talking like less than 5 feet per second for low velocity. To be considered medium velocity, we'll say between 5 and 25 feet per second. And for high velocity, we consider anything greater than 100 feet per second for sure. We consider high velocity, like a gunshot bullet. Now, the numbers I do want you to know is what are the resulting diameter sizes of the blood spatter. Well, remember, it's the opposite. So for low velocity, you actually have the greatest diameter. We actually have anything larger than 3 millimeters was considered from low velocity spatter. Low velocity like gravity. 1 to 3, medium velocity, and high velocity would result in blood spatter that's less than 1 millimeter. So let's say here we got a blood droplet. We measure. Hopefully I drew it correctly because let's see here, that's 1 centimeter. So that's Yes. Remember, there's 10 millimeters in 1 centimeter. Here we go. Let's use this guy. 8, let's say 8 millimeters. So yep, 2 millimeters and 1 millimeter. I mean, I drew them, I didn't actually, but there you have it. Gun spatter will always have the smallest because the force was fast, and the velocity that leaves the source of blood will also be fast, resulting in very, very, very tiny droplets. It's kind of like the opposite of what you might think. Something to note here is that, remember, there's very little mass in those tiny, tiny, tiny blood droplets. Well, tiny mass means, very little mass means it won't go very far. So the more mass a droplet has, the further it can travel. Just think of you scrunch up a paper versus a baseball bat. How far can they go? So that means that a gunshot bullet spatter will always be very close. Wherever it lands, the gun must have been, or the source of blood must have been very, very, very close to the source of blood. Those droplets will always be very close to the source of blood with that high velocity gunshot spatter. All right, very good.